In this lesson, we are diving in the world of factoring in algebra. We will start with the greatest common factor, then explore the difference of squares, and learn to factor trinomials, and finally, tackling complex trinomials. Whether you're in grade 9, 10, 11, or even first-year college algebra, this clear and beginner-friendly walkthrough will help you master factoring step by step. So here, we're going to start with the GCF, or the greatest common factor. So this first one here is the GCF, or the greatest common factor. To find out what we're going to factor out as the greatest common factor here, we look at the two numbers 3 and 6. We know 3 goes into both 6 and 3, so 3 is the greatest common factor. X squared and x cubed. X squared has a lower exponent, so this has to come out as the greatest common factor. And y to the 5 and y squared, this is lower exponent, so y squared has to come out as the greatest common factor. Now you open set of brackets, and to find out what you're going to write here, just take each term here divided by the greatest common factor. So this divided by this will give you x cubed. You have plus, and this divided by this will give you 2x. And this is your answer. Now the second thing here is the difference of squares. How do we recognize the difference of squares? It's always two terms. Both terms are perfect squares and the sign in the middle is minus. When that's the case, it's very simple. You open two set of brackets. Find out what the square root of 9x squared is, which is 3x. You put that here and here. And then you just throw a minus on a plus. Doesn't matter where. Could be a plus minus. And you do the square root of the second part of the equation, the second term, and the square root of 16 is 4. So you put a 4 here and here. And that's it, as simple as that. How about this? This here, is it the difference of two squares? No, it's not, because 3 and 48 is not. Because 3 and 48, they are not perfect squares. However, in this question number 3, you have to use both the greatest common factor and the difference of squares. So the first thing you take out the greatest common factor, which is 3, and if you factor out 3, you're going to get x squared minus 16. And now, this is a difference of squares. So you open two set of brackets here, put an x in each, because the square root of x squared is x, then a plus and a minus. Square root of 16 is 4, you put that here, and that's finished. Now, how about here? So here, basically, you open two set of brackets, and you throw an x in each one. Now you're looking for two numbers that multiply to the constant. So two numbers multiply to give you a negative 10, and add to give you negative 3. The two numbers that do that for you is negative 5 times 2. That will give you negative 10, and negative 5 plus 2 will give you negative 3. And that's basically what you throw in here is minus 5 and plus 2. How about here? Here, it's factoring trinomials, and then the difference, the greatest common factor. Because the greatest common factor from here, I could see right away it's 2. And then what I'm going to get in the brackets is x squared plus 1x, and we're going to have to write the 1, minus 6. Now you carry the 2, and then open two set of brackets, put an x in each. And now, looking for two numbers that multiply to give you negative 6 and add to give you positive 1. So multiply to give you negative 6 and add to give me positive 1. That's plus 3 minus 2. That multiplies to give you negative 6 and add to give you positive 1. How about here? So now this is what we call a complex trinomial. Why? Because we have a leading coefficient that we cannot factor out. So now what do? There are different methods that you use. There's the box method. There's the decomposition. But me personally, I prefer to do this using this method that I'm going to show you. So what I do, I take the 3 and multiply it into the negative 6, okay? So when I do that, I'm going to get x squared minus 7x minus 18. Now I factor this the same way that I did in here. So I open two set of brackets, put an x in each, and then what multiplies to give you negative 18 and adds to give you negative 7, it's negative 9 plus 2. But is this the answer? Of course not, because if you FOIL this, x times x, you're going to get x squared and not 3x squared, and you multiply negative 9 times 2, it gives you negative 18 and doesn't give you negative 6 because it's supposed to give me the original equation. So why did we do this? This is like a cheating way of solving this really fast, okay? But once you get this two products right here, or the factoring of this, you have to go back to this 3 here and divide each number here by the 3. So that will give you x minus 3. And the 2 doesn't divide by the 3 because here 9 divides by the 3, but the 2 doesn't divide by the 3. So what we do, we stick the x right, we stick the 3 right in front of the x here. And that will give me 3x plus 2. Now you see, if you multiply x times 3x will give you the 3x squared, and negative 3 times positive 2 will give you negative 6. And if you FOIL it, even the middle, when you add like terms, it's going to give you negative 7x. And this is basically factoring in a nutshell, covering the major part of factoring that you run into all the time when you're doing math from grade 9 all the way to first year university. You're going to be using these tools all the time. So great job making it to the end. By now, you've learned how to factor using the GCF, the difference of squares, and how to break down both simple and complex trinomials. Factoring is a powerful tool in algebra. And the more that you practice, the easier it gets. If you found this helpful, don't forget to like this video, share it with friends, and subscribe to Math with Sami M for more clear and simple math lessons every week. Thanks for watching and keep practicing. See you next time.